Hey guys, welcome to the third video that I'm making in preparation for my calculus final. So today I'm just going to be going over the divergence theorem for closed surface integrals. So if your if your surface integral is a scalar surface integral, can't use any theorems, just got to do it the hard way. But if it happens to be a vector surface integral, then there are some theorems that you can use in certain cases. So with the divergence theorem, you can convert your surface integral into a volume integral that looks something like this if your surface is closed. So what's a closed surface? A tennis ball, for example, would be a closed surface because it doesn't have any open holes. It doesn't have any holes in it. But then a Coke can, for example, wouldn't be a closed surface because it has a hole in the top. So yeah, you can sort of use that analogy to differentiate between the two. All right, I'm just going to hop straight into an example. Oh yeah, one thing I wanted to mention before I go over this example is that the reason, so why divergence theorem? So let's say we wanted to evaluate the surface integral for this cube and this vector field. We would have to set up 6 surface integrals because this cube has 6 sides. And we would have to set up 6 parameterizations for this cube, and that opens up a lot of room for error. But what we can do instead is recognize that this cube is actually a closed surface, meaning that we can convert our closed surface integral into a divergence theorem integral. So the way we set up this integral is the same way we would set up an integral or like a triple integral if we're trying to find the volume of this cube. So let's say we were trying to find the volume of this cube. We would do it in Cartesian because that's what any sane person would do with a blocky shape like this. So yeah, our integrand would be dz, dy, d theta. Z would go from 0 to 4, y would go from 0 to 4, and x would also go from 0 to 4. And that is roughly what our divergence theorem integral would look like. But there's a divergence term in the middle. So let's solve for that first. Let's find the divergence of this vector field. So as you all remember, it's just this function, or like the x component of the vector field, differentiated with respect to x, plus the second component differentiated with respect to y. It's different in different coordinate systems, but in this case we're working with Cartesian, so yeah, it is what it is. So the third component we would differentiate with respect to z. So there aren't any y terms in here, there aren't any z terms in here, so both of these zero out. This term, however, has an x term, so differentiating with respect to x, we get 2xy, and that is the divergence of our vector field. Righty. So what we're going to do is we're just going to plug it into, let me full screen real quick. Okay. So we're just going to plug it into our volume integral. It's just going to fit in, it's just going to fit inside just like that. So let's differentiate with respect to z first. So there aren't any z terms, so this would just, a z would just show up. Still gotta integrate with respect to 2 other variables. So z from 4 to 0, or z from 0 to 4 is just 4. So we have 8xy dy dx spread to two more variables. Now, the integration is simple, so I'm just going to go straight to the answer. I'm just going to write down the answer. It's 512. So yeah, this is going to be a short video because there isn't much to say about the divergence theorem. Yeah, I'm just going to summarize what I went over. Okay. So the divergence theorem for surface integrals is only for closed surfaces. So tennis ball is a closed surface because it doesn't have any holes. A Coke bottle is an open surface because it has a hole in the top, meaning that if you had to evaluate a surface integral for a Coke bottle, you can't use the divergence theorem. And why would you want to use the divergence theorem? Because for shapes like cubes, you'd have to set up 6 surface integrals. That would be a huge pain. But by recognizing that it's a closed surface, you can just use the divergence theorem. And yeah, that's all I wanted to go over in this video. See you guys in the next one.